Okay, started the recording. So basically now we are going to try to model or to get probabilities, okay, of number of network failures in a week, okay. Like we want to know, that is how many times is our network maybe will fail this week, or that is the probability that maybe our network will fail like 3 times in this week, or 4 times in this week, or even 5 times come next week. Okay, so our objective here is now to get what? The probability. All right, so with that we I'm going to use two methods. We have the manual calculation, okay, meaning we will have to calculate all these parameters, okay. Then we will have the second, that is the second, that is example. Now on the second calculation method, we'll use Excel inbuilt function, okay, to calculate now those probability density functions, okay. So with that we can now start with the lambda. Remember yesterday I told you lambda, it is what? It is the mean and also variance of this distribution, okay. Or this constant, it might not be lambda, it might be another constant, okay. So basically this constant is always equal to the mean of the what? Of the Poisson distribution. As well, I said that Poisson distribution is the only now distribution where mean and variance is what? It's equal, okay. All right, so we can now try to that is calculate the mean of that is of this number of events, okay. So lambda, it is the mean of the number of events. So what we are going to do is to calculate the mean of what? The mean of the events, and then we'll use that as what? As our lambda. So it will be average, okay. Remember mean, we said it's the simple average. So we will have 4, okay. We will have 4. We can even go with a constant value. Let's go with 4. So we are going to say 4 will be what? Our lambda value, okay, all through. 4 will be our that is our value, okay. So I've just used the sample mean as what? As our lambda. Then we now need the second part. So already we have lambda. Now we will need to calculate the exponent of our lambda, and then also we'll that is calculate lambda raised to x, okay. And x, remember, it is the what? It is the number of events. So it will be equal to exponent. Let's use the Excel inbuilt function for exponent. Then we need the exponent of negative 4, okay. Yes, we have an that is an exponent of negative 4. I think is someone having a question? Yes, Brenda.
I'm requesting you zoom out a little bit.
Okay, all right, so let me zoom that. Okay, Claire, I will share the data, that is the data set with you. Okay, I will share after this class. I will share the data set, maybe for your practice. Okay, so now this is the exponent. I've said we are going to use the Excel exponent function. Okay, yes, you can. Okay, okay, all right. It was a reply. So it will be exponent of negative 4. Okay, so with that we can now we have now, or we've now obtained our what? Exponent of negative lambda. Okay, good. Now let's go to that is lambda raised to, this is lambda raised to, let me correct that. This is lambda raised to x. So lambda raised to x, we have lambda already. So we are going to say it's equal to lambda raised to what? Raised to power x. And that you will see that is our that is the values will continue what? Will start increasing. Okay, you can see it is kind of having a shape because the data is what? Is increasing. All right, then we have now the that is the factorial. Now we need to calculate the factorial for the number of events. So it will be equal to that is 0 factorial. 0 factorial, it's always 1. So we will use a factorial that is formula here, and it will be equal to fact. Okay, fact will return that is the the factorial of what? Of our number. So we'll say fact, then factorial of that value. So factorial of 0 will be what? Will be 1. Okay, then as well it will increase as we what? As the number of events increases. Okay, all right, now we are on the what? We are now on the last part. Okay, and on this last part now it's when we want to do what? To calculate the probabilities. Okay, that is the probability of maybe one event occurring within a week. Remember, week now brings the periodic part of that is the distribution, because we say that it calculates the probability that is density function of what? Of the number of events within a given what? A given period. That's how we defined Poisson distribution. So now on this, from the formula here, we are now just going to use now this formula, and for this formula we are going to say it is equal to, okay, now let's start with the numerator. So it will be e raised to negative lambda, there it is, then multiply by 1 raised to that is to x, then divide by what? X factorial, divide by this, and then you will get what? You will be able to get the probabilities. So when you drag it down, you can see now we've that is we've gotten what? The probabilities. Okay, and I have used conditional formatting over this. Let me just remove the conditional formatting. So I did conditional formatting so that I might be what? I might be able to get the highest what? The highest probabilities. Okay, because you can see from the that is from our that is number of events, you can see it is likely to get between what? To get between 2 to 5 network failures in a week, because you can see at this point is where that is our probabilities are high. Okay, let me color code that. So I'll go to conditional formatting, then I will go to color scales, and I will choose whichever I want. So let me choose that is red to be what? To be the to give me the highest values. So you can see between these values, you can see the probability, it's high here. Okay, the probability, in fact, it's high here. The probability of us getting 3 or 4 network what? Network failures in a week. Okay, why not 1? Okay, this is because if you get that is a network failure, okay, of like once, maybe that might be like because of I don't know what I can explain. Like it might be very in rare cases, okay, meaning your network has been very stable. Okay, so if it has been very stable, then maybe probability of getting a failure will be what? Will be very minimal. And you can see it is even less than 0.07. But if now we are talking of 2, 3, 4, it means maybe you usually have a consistency in network failure. Like for example, we have that is done some research and seen maybe your network maybe drops or fails, and which majorly happens. Like for example, in a day, in most of the organization, more so if you are using third party, third party to provide you the network to you, then definitely you will what? You will have some network failures, even if they won't last long, but they will. So in that case, the probability of getting 2 to 4 network failures will be what? Will be higher compared to that is to getting 16. Now, for you to get 16, it is now very extreme. And you can see here it's very small because it is raised to negative zero point 0.6, raised to 10, sorry, multiply to 10 raised to that is to what? Raised to a negative 6, meaning we have 6 decimals before this, which is very very small, what? Small value, okay, in terms of probability. So with that, you can see now that is we can do what? We can get or we can it's the probability of getting to that is network failures, it is high, okay, or 3 or 4, okay, it is very high. So in this case, the number of what? Failures, network failures, they are our events. All right. Okay, so maybe how can we do that? Maybe how can we or present this distribution now in a graphical what? In a graphical presentation. How can we that is how can we present it? So to present it, you'll definitely use the number of events and the as your x, you can see, and then the probabilities now you will use as what? As your y. Okay, so with that you can just highlight the data all through, and also highlight the data on the what? On the that is on the number of events. Then go to insert. After insert, go to recommended charts. Of course, we might, in terms of if you want a line distribution, then you'll get something like this. But since this is that is discrete distribution, it's always advisable to present it in what? To present it in terms of what? In terms of or using bar what? Bar graph. Okay, using a bar graph. So you can see that is how the probabilities are being what? Are being distributed. And you can see at event where we have 2, 3, 4, and 5, you can see we have what? High probability of that is 2 events, 3 events, and 4 events occurring. Okay, and the that is the highest probability is what? It is between 2, it's between 3 and 4, because you can even see we are having what? The same value. Okay, you can see we are having the same value, meaning this is the optimum number of events, okay, which can occur. Maybe the network failure can occur within a week. Okay, all right. What about like if we vary, maybe if we vary the average? Okay, maybe like for your data, or let's assume maybe for the last maybe 18 weeks, okay, or for the last 17 weeks, the average number of that is the average number of network failure, it is what? It is 8. So meaning we have averagely 8 that is averagely 8 and network failures, okay, per week or in a week. Okay, so with that you can we can change maybe the average number of events to 8. So like for example, if I change 8 here, you will see also that is how that is the graph will do what? Will behave. So you can see if we increase the number of that is the average number of events occurring, okay, then you can see now that is the probabilities tend to shift around that is towards what? Towards where we have that number of events, okay, and you can see the optimum number of events now per week will be what? Will be within this area. So it will be within 7 and what? And 8. Okay. And you can see now the distribution, how it has been what? It has been distributed. It's now moving to a more that is symmetrical what? Symmetrical shape. Okay. But it's always good that is unless you have this historical data which is showing consistency in terms of that is the average number of events, then you can use that. But if you don't have consistent data, then it's good to do what? To do the average of all the events which have ever happened within that week. All right, that's all for that is for the manual way. So we can just do the formula for that is for the Excel inbuild and see if our calculation was correct and if we are getting what? The same values. Okay, so with this it will be equal to, this is Poisson distribution. So we have a Poisson distribution like Poisson dot dist. Okay, so you can see it will return the probabilities of Poisson distribution, or it returns the Poisson distribution. Okay, so with that we are going to use the formula that is Poisson distribution. Okay, then we have the x, we have the mean, and we have what? Now with that we shall select if we want cumulative or we want density function. So with this, definitely the formula will guide you. So we'll need what? X. X is the number of events. So you'll go to X, comma. What else do you need? Mean. Mean is what? It's lambda, comma. Then what do we need? Do we need cumulative um, cumulative distribution function, or do we need probability mass function? For our case, we need the probability mass functions because cumulative that is distribution function, it will basically give us like the sum of all these what? The sum of all these probabilities. Okay, so it will be we'll go with the probability mass function, okay, or density function. So with that, now we can do what? We can drag down and you can see we are getting the same value, meaning our calculation was what? Meaning our calculation was very correct. So I can just copy paste the that is the formatting here, and you can see we are getting the same values, okay, and the same trend in terms of probabilities, okay, meaning that is we did not make a mistake when we were what? When we were doing the manual computation. Any question? Any other question? I'm done with the Poisson distribution. I'm done with the Poisson distribution. So maybe the remaining part is for you, maybe to do that is on practice. Okay, you can come up with a project, even in your what, in your that is in your work area, and do that is some probabilities. If maybe you are in a call center, you can try to find the probabilities of receiving what, of receiving maybe a certain number of calls in what, in an hour. So with that, it will help you, that is to get like to prepare well. Okay, yes, to prepare well, depending with what, with the historical data. So with this, it's also good in terms of forecasting. So basically you can go and do what, you can go and search more, and even work on on other examples on the same. Okay, okay, you can always vary the number of events. Okay, you can always vary the number of events to what maybe you want. Good. Any question on Poisson distribution?